Okay, this final section is about forestry management, and this first slide is timber volume as a function of time. So you can see on the vertical axis we have timber volume, and then we have time on the horizontal axis, and then we have this thing called carrying capacity, which is similar to um, the carrying capacity for fish. And forest growth increases at an increasing rate initially. So you can see that increasing rate going on there. But then it goes at a decreasing rate. And then finally to zero at the carrying capacity of the forest. And so, this is a nice example of diminishing returns again. Now this is without any human involvement whatsoever. Now we bring humans involved, and humans are looking at the harvesting of the tree or the cutting down of the tree. Here we have a picture of eucalyptus trees here. And what do humans look for in the shall we say optimal amount of the trees to be cut? Well, it can and probably should depend upon the differential between the growth rate of the tree and the interest rate received when the tree is sold. If the growth rate of the tree is greater than the interest rate, don't cut the tree. One can make more in the next period relative to what one can make if one just cuts the tree. However, the marginal benefit of keeping the tree will decrease and eventually intersect with the marginal cost, which would be the interest rate. So eventually there's going to be a point where cutting the tree is the optimal thing to do. And you wait until those two curves are indeed equal. And that leads us to this final slide here, and that's exactly what this is showing. We have the marginal benefit of waiting, which is going to be downward sloping, and the marginal cost of waiting, which is going to be upward sloping. And I'll just read from the insert here. The marginal cost of waiting to another year of harvest is the interest that could have been earned on the timber value, and the land value minus the cost of harvest. Oh yeah, this is the extended version. The timber value, and therefore the marginal cost, is low, but increases to the maximum as trees grow, and eventually decreases as the trees stop growing and is subject to disease, death, and forest fire. The marginal benefit of waiting another year to harvest is a change in the timber value minus the standing value for recreation, animal habitat, scenery, carbon sequestration, and the like. You harvest when the two are equal. The marginal benefit will increase and decrease with the growth rate. The optimal rotation period, or shall we say when one cuts, is when the marginal benefit is equal to the marginal cost, the intersection of these two lines. After which the marginal cost of waiting another year exceeds the marginal benefit. Alrighty, and that finishes off chapter 13.